Good morning, everyone.
Good morning.
All right, so I got the exam 2 graded, and I submitted those, and you should be able to see a copy of your exam, and then it'll have anywhere I took off points. I haven't done anything to the grades as far as a curve or anything. I normally don't do a curve, but what I think I'm going to do for this exam is allow for test corrections, and then those corrections will allow you to receive a certain % of your points back. So just for example, if I took off 10 points and you do corrections, then maybe I'll give you like 3 or 4 points back. But those corrections, those will be due on what's today, Wednesday. So those will be due on Monday. And what you'll have to do is just resubmit just your corrections to the same Dropbox that we use for the test. So just send me a new file that has what problems you corrected. And let's say that that'll be due Monday before class starts. So Monday at 9 a.m.
Thank you.
Okay, any questions on that? Okay, so the grades were pretty dramatically different than the first exam. So what you can see here on this chart on the right is the blue is the exam 1 grades, and the exam 2 grades are in the orange. And so you can see, I believe every student came down, and there were some pretty dramatic changes. So I don't know, I wasn't sure what to expect. I know that there was a lot of information on this test, but while I was grading it, I could tell that there were some students who really were struggling with it. So the grades kind of reflect that. The average on the test was a 65. Comparing that to the first exam, which was an 85. So that's a 20-point swing in averages. And also our standard deviation here doubled. So that means that not only were the exam grades lower, the class was spread out further in terms of their grades. And you can see that from the orange. We go from a 96 down to a 13, where on the first exam we went from 100 to like a 67 was the lowest. So yeah, I mean, it is what it is. The material gets harder, and people don't do as well. It's just the way it goes. So do the corrections. The most important thing is for you to learn the material to help you get into the next class, Cal 1, because all of this stuff comes back at some point. So you just want to be to a comfort level with it. You can get into Canvas and you can go to your grades, and I believe it lets you do like hypothetical, like it allows you to like fill in grades, right, for the remaining exams. I can't show you that because I'm not a student, but you should be able to fill in the grade for the final exam to be able to tell like what you need on the final to get certain grades. So using that information, kind of see where you are. And I just have to remind everyone that April 16th, that's this Friday, is the last day to drop a class. So if you feel like, you know what, I really want to, I want to get through this class with an A or a B for my GPA or something like that, and it looks like you're not going to be able to get an A or B, then that might be, a reason for you to drop. Or if you're just feel like, I just want to redo this when we're back on campus or something like that, whatever. The deadline is this Friday. So you have to submit your drop request through ACES, or if you can't figure out how to do it, make sure you email me, or if you're taking another 16-week class, this for all 16-week classes, make sure that you contact your professor by Friday if you can't figure out how to do it on ACES. Are there any questions on that? Okay, so I've been thinking about how we proceed from here. The stuff that we've done, like I said, will come up again in later classes, but I thought it would be good today to just start, just clean slate. Let's just move into chapter 9. And if we need to come back and revisit something from chapter 8, we can do that. But chapter 9, it stands alone by itself pretty well. I mean, of course, we'll need to know certain things, but I think it would be good for us to just proceed right now than to go back and try and kind of relearn some of the things that maybe we didn't do well on the exam. So with that said, I think I'm going to get going on chapter 9, section 2. And that's where we are on the schedule. Bring this back up. So chapter 8's over. We skipped 9.1. 9.1 has to do with right triangles. And so we already know some things that we need to know about right triangles. So we're going to go to 9.2, then 9.3, and then right away we jump into chapter 10 after that. Okay, so that's kind of where we are. And 9.2 is a very important law. It's really just a set of equations that we can use. And what the law of sines allows us to do is solve for all the sides and all the angles of a triangle which is not a right triangle. Okay, so the important thing is what we're going to be looking at today are triangles that are not right triangles. We already know, okay, what we already know about right triangles is that if we have a right triangle, I've labeled one here, A, B, C are the sides. I put theta and beta in here. First thing we know is that theta plus beta has to be 90 degrees. And that's because if this is a 90-degree angle and the sum of all the angles of a triangle has to be 180, then if this is 90, that means these two together have to be 90 added up. So we know that about right triangles. We also know a squared plus b squared is c squared. That's a Pythagorean. We've been using that for weeks and weeks and weeks now. And then we have all the trig stuff that we've learned, right? If you look at this angle theta, it has an opposite and adjacent side. And then the hypotenuse is c. And so we have the sine, cosine, tangent of that angle. And then if you look at beta, beta is a little weird because when you look at beta, the opposite side of beta is this side, and the adjacent side is this side. And then the hypotenuse is here. So when you do sine of beta, it's opposite over hypotenuse, it's a over c, right? So you kind of have to turn your head sideways and look at it, I guess, if you want to kind of look at it like the standard way we draw the triangle. So this is kind of what we already know about right triangles, all right? We know a lot. So the question becomes, if we're given a triangle that's not right, then can we still figure out what all the sides and what all the angles are? Okay, and that's where the law of sines comes in. So first, some definitions. If you have a triangle where none of the angles are right, okay, so if none of the angles are right, then we call that an oblique triangle. Okay, so an oblique triangle is just a triangle that is not a right triangle. And it turns out that when you have an oblique triangle, you only have two possibilities in terms of how you could draw them. You could have a triangle where all three of the angles are acute. And remember, acute means that they're less than 90 degrees. Okay, so that's one possibility. Or you could have a triangle that has two acute angles, those two, and then the third angle here would be obtuse, which means it's bigger than 90. But that's it. There's no other way to draw a triangle that's not a right triangle that would be different than those two. Okay, so we either have to have three acutes or two acutes and an obtuse. Is that all right, everyone? In both cases, those are referred to as oblique. Now, for the general sake of where we're going to, or what we're doing, we're going to have like a standard drawing that we're going to use for the rest of this section. And that is this drawing right here. Notice this is not a right triangle, right? Excuse me, this is not a right triangle. And because it's not a right triangle, we're not going to use the same notation we used for this. What we're going to do is we're going to label the angles capital A, capital B, capital C. And then the sides that we have, are the ones that are opposite of the angle. So the side that is opposite of the angle C would be little c. The side that is opposite of the angle capital B would be little b. And then the side that is opposite of capital A would be little a. All right, so that's going to be our standard kind of drawing from here moving forward. All right. Okay, so without further ado, let's move on. So when we try and solve an oblique triangle, okay, when we say let's solve the triangle, it means, like I said a second ago, it means to find the lengths of all of its sides and to find the measures of all the angles. So anytime you're asked to solve a triangle, that means go figure out what all the sides are, go figure out what all the angles are. To do this, we'll need to know the length of one side. Okay, so in order to solve any triangle, we will have to have the length of one side. Okay, so we have to have one side along with, and these are different cases. Okay, so I'm going to look at this instead of reading this up here. We could have one side with two angles that are known. We could have two sides and an angle that is opposite to one of them. We could have two sides and the included angle. I'll explain what that is. Or we could have all three sides. So we have these broken down in most textbooks give you like these little acronyms to kind of help you. Like this means you have the angle, side, angle. This means you have side, angle, angle. This means you have side, side, angle. This is side, angle, side. This is side, side, side. I personally, just me personally, as a student and as a teacher, I don't care about all that. Like, give me a triangle. I'm going to look at it. I'm going to analyze it. I'm going to figure out what I need to do to solve the sides. I don't like getting fixated on, oh, this is angle, side, angle. So this is what I do, like a robot, not paying attention to anything, just following a process. Does that make sense? I want to think about critically what is in front of me as opposed to these cases. But this is the way that the book presents it, okay? So now let's get to the law of sines, okay? The law of sines. The law of sines says this. And by the way, these cases we have, the law of sines will only deal with these two cases, okay? That's all the law of sines will allow us to do. Cases 3 and 4, where we have two sides and an included angle, or three sides, that is the next section called law of cosines, and that comes up. So we can only do half of these today, and then we'll do the other half when we do law of cosines, all right? So I put that right here. Law of sines is only case 1 and 2. All right, so here's what law of sines says. It says if you're given a triangle, okay, with sides A, B, C, and opposite angles, capital A, capital B, capital C, respectively, then this is true. So I'm going to move this down. I'm going to bring that drawing of the triangle we had here and bring it over here so we can. All right. So here's what the law of sines is saying. It says if we have a triangle like this, right, labeled the way we have it labeled here, then sine of the angle A. So right now you need to completely remove from your head the idea of sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Just erase that from your mind, because that only works on a right triangle. This is simply saying that if we take sine of this angle, okay, so sine of A means if we take sine of that angle and divide that number by little a, that ratio must be equal to, and this is the important thing, it must be equal to the ratio of sine of B over little b. But that must also be equal to sine of C divided by that corresponding side. So the ratio of sine of the angle over the opposite side must be the same for all of the sides and angles. Okay, Now, I'm not going to prove that this is true. There's a proof in the book, and I'm not going to take the time to do it. We're just going to believe it's true. But I also want to add something to it that the book doesn't state, and that is that when you use the law of sines, you are free to flip everything over. So this law of sines can also be written little a over sine of capital A must be equal to little b over sine of capital B, but that must be equal to little c over sine of capital C. Okay, so at any point in time, if you're using law of sines, you are free to flip the fractions over and it's still all true. Okay. All right, so now let's try and do a problem and see how we can use the law of sines to solve the triangle. So what I'm going to do here is I'm going to paste this guy here. All right, and try and use the law of sines. So I'm given that the angle A here is 40 degrees. So I'm just going to label this triangle. This is 40 degrees. And I'm given that angle B is 60 degrees. So this is 60 degrees. And I'm given that the side A is 4. Okay. So everything in yellow, I have. Everything in green, I need to find out. Okay, that's what I need to figure out. So who wants to start? Is there anything that we know just right off the bat we can just tell without doing any work, really?
We can tell C, right?
Capital C, the angle. What can you tell about capital C?
We have sine A and little a.
We do have sine A and little a, yes. What I'm saying though, before we do that, is there anything that we can just say right now we know the value of without even using the law of sines? And Anna Marie, I think you said capital C, but you never said what about capital C?
We could figure out what it is, right?
Yeah, how?
By adding up A and B and subtracting it from 90.
Yeah, so look, we know that the angle A plus the angle B plus the angle C, when we add up all those angles, what does it have to be?
Right. 180 degrees.
180 degrees. So we have to know that going into this. If you have a triangle, right, the sum of all of the angles must be 180 degrees. So if we have two of the angles, then we should be able to get the third without any work, right? Well, I mean, there's some work. There's a little bit of arithmetic, right? 40 and 60, that's 100 degrees. So we would need to have this be 80, wouldn't we, to get 180? So without any work, I'm just going to put here on the side. Let me see what we want to know what capital C is. We want to know what little c is, and we want to know what little b is. So this is kind of what we want, right? We want this. We want these three things. Capital C, we know, is 80 degrees just by looking. Any questions on that? Why it's 80? So we're good there? Okay. All right, let's go after trying to get little c. Okay, let's go after little c. And somebody said it, and I didn't see who. Somebody said that we have capital A and little a, right? Do y'all see that? We do have capital A and little a. So in the law of sines, I know what capital A is. I know what capital A is, and I know what little a is. And I need to find out what C is and B, but let's go after C first. So when I look at these equations that I have up here from the law of sines, I'm going to look for the equation that has little c up on top, which is right here, this right here. I'm going to write that down. Little c over sine of capital C must be equal to this one or this one, right? It's up to me which one I want to use, because if they're all equal to one another, then that means that this is equal to this, or I could say this is equal to this. So I'm going to use this one, A over sine of A, because again, the things I know little a, I know capital A, and didn't we just find capital C? right? We have little a, capital A, and big C, capital C. So all we don't know here is little c. And so we should be able to solve this. So let me continue. I'm going to write little c over sine of 80 degrees. And that's because we already said c was 80 degrees. Must be equal to little a, which is 4, over sine of capital A, which is 40 degrees. Now, sine of 80 degrees and sine of 40 degrees, those are not common angles. Would you all agree with that? Those are not common angles. So in order for me to continue this, make sure I'm in the right place. So in order for me to be able to actually figure out what little c is, what I'm going to need to do is get my calculator out. And I forgot I was going to send you all an email to tell you to make sure you have your calculator today because we need it, right? So what I'm going to do right now is on my calculator, I'm going to figure out what sine of 80 degrees is. I'm also going to need to find out what sine of 40 degrees is. And to do this, don't do it yet, okay? Don't do it yet, but make sure that when we do it, you're in degree mode on your calculator, right? You can be in radians or degrees. Here we're in degrees because everything is given in degrees. So before I do it, here's what I'm doing, okay? I'm gonna try and get c by itself. So to get c by itself, I'm gonna clear the fraction out. I'm going to multiply sine of 80 degrees on the left and sine of 80 degrees on the right. And it'll cancel over here, which leaves me with c. And on the right, I have 4, and that sine of 80 is in the numerator, and then over sine of 40 degrees. That's what I need to do on my calculator. Is everyone clear on why the sine 80 is on top? Yes. Okay, so that's it. Let's do that. Now, I would like for you, if you have your calculator, to do this because every calculator is a little different. I'm going to try and do all of this at one time on my calculator. Okay, I'm actually going to type into my calculator right now. This is the way I'm going to type it. I'm going to do 4 times sine of 80 degrees divided by sine of 40 degrees. Type it all in at one time. And yes, I'm in degree mode. Somebody want to share with me what they got?
Yeah, I got 6.13.
Yeah, 6.128, something like that. I'm put 28. And so, well, unless they tell us otherwise, let's just round it 2 decimal places. Okay, so I like that. Let's go 6.13. And this is C, 6.13. Okay, there we go. So now we know what C is, right? Little c. We still need little b, right? So for little b, I'm going to do the exact same thing. I'm going to go back to the formulas. I'm going to use the one that has little b on top because that's what I'm trying to solve for. I take little b over sine of b, and I can set it equal to either one of these now. So that was my first piece of work here. Now I'm going for b. So I'm going to put b over sine of b equals, okay, which one do you want to use? Do you want to use, do we want to use little a over sine a, or do you want to use little c over sine c? Do we have a choice here?
I thought it was, I mean, yeah, we do now because we found B, but I just thought it was easier to use A. It's just more consistent.
Yeah, so we could use either one because we actually know little c and capital C, right? So we could use little c over sine of capital C, but we could also use little a over sine of capital A. Josh brought up that it seems more consistent to use the A. I would recommend using the A because what if you got the C wrong somehow, right? Like what if you made a mistake on the C? Then you're guaranteed that this is going to be wrong too. So I always recommend using the given information which is the A over sine of A. Because you know A, little a, and capital A, you know that those are right because those were given to you. So now I'm going to write B over sine of capital B. We know that capital B was 60 degrees equals A, which we were given was 4 over sine of capital A, which is 40 degrees. I'm going to clear the fractions again. So I'm going to multiply both sides by 60 degrees. They'll cancel out on the left. I'll get B is equal to 4 times sine of 60 degrees over sine of 40 degrees. Now I realize that 60 degrees was a common angle or is a common angle. However, 40 degrees isn't. So you're still going to need your calculator here, no matter what. So let's do that. Who has that one?
5.39.
Yeah, 5.39. We'll round it 2 decimal places. 5.39. So 5.39. And we are done. We have solved the triangle. We know all the sides. We know all the angles. And so we've completed the problem. Any questions on that? All right, good, good. Let's do another one. For this one, I'm not going to draw a triangle. I'm not going to bring that triangle in here and label it. I want to see how much of this we can do without the triangle. So maybe we start out with what we want first. So what is it that we're going to need to find in this problem? So what's missing?
We
Capital
can find
C.
big C.
Capital C.
Small
little
a,
little
small
b.
b.
Yep. Okay. Can you tell me any of those just right off the bat?
C, capital
C,
C.
capital C, right? The angle. And so what would it be? Because we know 2 of the angles, right? 35 and 15. If we add those up, we get what? 50?
130.
So that means capital C has to be 130. Okay, well, that's good. So let's go after little a. And since little a is what we're looking for, I'm going to write down little a over sine of capital A must be equal to, okay, so what are we going to use? We can use B over sine of B, or we can use C over sine of C. Which one are we going to use?
C over sine of C.
C, right? We have to because we only know little c. That's all we know. So I'm going to use little c over sine of capital C. And I'm going to highlight in yellow here the things we know. We know capital A, we know capital C, and we know little c. So that means we should be able to find what little a is. So A will be sine of capital A, which is 35 degrees, equals C, which was 5, over sine of capital C, which was 130 degrees. Clear the fractions again. So sine of 35 on both sides. And we get little a must be equal to 5 sine of 35 over sine of 130. All right, I'm going to call on some people. All right. Leslie, you here?
Sorry, yes.
Okay. Are you able to do this on your calculator or no?
Yes.
Okay. Did you get something yet?
No, sorry.
Okay. Go ahead. I'll give you another second or two.
5 sine 5 times sine 35 divided by sine 130. So 3.74.
Yep, I'm getting the same thing. 3.74. So now we know what little a is. Good. All right. Now we go and try and find little b, and we just basically set up another law of sines and do the same thing. So we go little b over sine of b, capital B equals, and let's just use the same thing we had a second ago. Let's just use the c and the sine c again. So that'll be 5 over sine of 130. And oh, b was 15 degrees, sorry. Cross multiply, or not, sorry, please withdraw that. I did not mean to say that. Clear the fractions. All right, Tyler, are you here? I don't see Tyler.
I have a quick question.
Yes, go ahead.
If you were to cross multiply, it'd be more steps, but would you still get the same answer?
Would still be correct. Yep.
Okay.
Yeah, because if you cross multiplied, right, you'd bring this sine 130 here, and then the sine 15 here. But because you're trying to get b by itself, you would then be dividing the sine 130 back. So it's kind of, yeah, it's just an additional step. Okay, Angelique, did you get it?
Yeah, I got 1.69.
Anybody else get that?
I got that as well.
Okay, 1.69, we'll go with that then. All right, there we go. So what do y'all think? I mean, relative to what we've been doing, like identities and solving trig equations, this seems a little bit lower level. Yeah, like not as bad.
For
You
sure.
agree? Yeah. Okay, now let's look at the next one. All right. So we're given A, C, and capital C. So that means we want to find, let's see, in terms of angles, we're missing B, we're missing capital A, and we have little a, so we need little b and we need little c, right? So we have, I'm sorry, we just need little b. So we have little a and little c, so we need little b. We have capital C, so we need capital A and capital B. So what do y'all think? Can we figure out what A and B are just by?
Would you do 180 minus 50 and then divide by 2?
Well, that would mean that A and B would have to be the same. There's nothing that says that they have to be the same. So what we know is this: A plus B plus C must be 180, right? We know that for all triangles. If we know that C is 50, so that means that A plus B has to be 130 if I subtract 50 on both sides, right? So I think what you were suggesting is, could we just take this and divide it by 2? Well, that could be true. It could be true that A and B are the same angle, but it could be that this is 100 and that's 30, or this could be 90 and that could be 40, right? So there's infinite number of possibilities. We can't just assume that they're equal. So from this, we cannot determine A and B. We can't do it, right? We have to have 2 of the angles in order to figure out the third. That makes sense, Cameron?
Yeah, that makes sense.
Okay. All right, so what are we going to go after then? I mean, start looking at what you have, right? You have A, but do you have anything about a capital A?
Well, you could find capital A.
Okay, how?
So I would just do the same thing we did to find the sides. Instead, I would get what the value of sine A, correct?
Mm-hmm. Mm-hmm.
And then we could use that to subtract from 180, and then we find what are we lacking now? So we got C, so B.
Yeah, you're definitely on the right track. What I think is important for everyone to see when you're using law of sines is that in order to use the law, you've got to have at least one of the angles and its side. Like you have to have capital A and little a, or you've got to have capital B and little b, or you've got to have capital C and little c. You got to have that because that allows you to set up one of your ratios. Then the other ratio you set up depends on what else you have.
Could we use arcsine of that number we get to find the angle?
We are going to have to. Yes, we're going to have to. So Josh, do you agree, Josh, that we have little c and capital C? Right, we do.
Yes.
So I could go back to this, and it's kind of like we have this, don't we? Or if you look at this one, we have this one.
Mm-hmm.
Those two, we could set it up this way, or we could set it up this way, couldn't we?
Yeah.
Okay, now the other information we have is something about little a.
Mm-hmm.
So since we have little a, why don't we go after capital A first? Think
Right.
about that. We have capital C, little a. Let's go get capital A. All right. And then we can set up the relationship. Now we're trying to solve for capital A. So watch what I do here. I'm going to write the law of sines this way. Sine of capital A over little a equals sine of capital C over little c. See how I'm using them in the other version flipped over?
Mm-hmm.
Instead of having the little numbers on top and the signs on the bottom, I'm doing the signs on the top and the letters, the small letters on the bottom. That's because I'm trying to solve for sine A. And anytime I'm trying to solve for something, I always like to leave it in the numerator. If you go back and look at the previous problems we've done, everything we've been trying to solve for, I've always made it be on top. Okay, and that's because the algebra is better if what you're trying to solve for is on top. If it's in the denominator, you have to get it out of the denominator, which complicates the algebra. So are there any questions on why I'm about to use this? I know this, I know this, I know this. I'm going to go get capital A. So let's just fill everything in. Sine of capital A, I don't know what that is, over little a, which was given to me to be 2, must be equal to sine of capital C, capital C we know, right? That's 50 degrees, over little c, which is 1. Now, again, I'm trying to solve for sine of A, or A. I'm trying to solve for A. So what I'm going to do is clear the fraction on the left-hand side by multiplying both sides by 2. That'll clear. And it'll leave me with a new equation here. Sine of capital A equals, that 2 can just go in front of the sign. Please do not make that sine of 100 degrees. That 2 is never allowed to go inside like that. It just slaps out front. So go ahead now, do sine of 2 times sine of 50. Someone want to give me that?
1.53.
1.53. Okay. Now, something weird is about to happen. If we were to try and solve for A right now, this is what Josh was bringing up. Could we use the inverse sign or the arc sign or whatever? Yeah, if we want to get A out of the sign, what we could do is arc sign of the left side equals, and then do arc sign of the right side. On the left side, we should just get A. And that's because when you put arc sign together with sine, they just kill each other off. And over here, we just need our calculator, and we need to use our inverse sine function on our calculator. So again, that on your calculator should be a key that has sine with a little -1 on it. Try and use that and do 1.53 and tell me what you get.
I get an error.
You get an error. Uh-oh. Okay, so that's not a mistake.
And I did both radian and degree, and I still got errors in both.
Yeah, you're getting an error. So think about it this way, okay? Just try and just back up for a second. This is a sine function, right? What is the amplitude of this sine function? What's the number in front of it?
1.
1. Okay, so if you were to graph that sine function, it goes up and down, but it's stuck between -1 and 1. Would you agree? And we're saying, where is it equal to 1.53? Well, it can't be 1.53. That's outside of the range of the sine function, which means that there is no solution here. Which means what? This is weird. Okay, this we obviously haven't had this happen, but I'm going to explain what's happening with the picture. So if I come back to this, let me slap this guy in here. They told us that C had to be 50 degrees. This had to be 50 degrees. And little c had to be a 1. And then they told us that A had to be 2. Okay. What we have just determined by getting an error is that it is impossible to draw a triangle like this. You can't do it. Okay, it's impossible. And the only way to really kind of see that is to actually physically try and do it. So let me see if I can do this. It's going to be hard. So let's say that I'm going to start drawing a triangle, and I'm going to say that this side right here is 1. Okay, and then the other side of the triangle over here is twice that. So there's 1, and then here's 2. But I'm telling you that this angle in here has to be 50 degrees. If I physically try and draw this, see, I have to actually have like a ruler or something. If I were in class, I could do this very easily just on a board. We just do it with rulers, and we would see there's just no physical way to make a triangle like this.
I put it into an app that builds triangles,
Oh, really?
and it looks like
Oh, that's cool.
it looks like
What is
that.
that? What is that app? You just give it the angles on the sides?
Yeah, it's just online. I just Googled triangle.
Can y'all see that? I'm going to go to a website and see if I can do that. That's cool. Triangle builder. Man, technology is just too awesome. Triangle maker. Let's see if this works. Okay, so what? So if I can make one side 2, oh, that one was already 2. So I'll make one side 1. And then this angle here, we need the angle. So this side's 2. I need this angle right here to be 50 degrees. Yeah. I can't make it 50. Close enough. So if I try and make this side, see, all I can change now is this side. Do you see that I can make this side whatever length I want, and I can even change this angle however I want to change it, but I'm never going to be able to connect these 2 dots together, no matter how I do it. Okay, this triangle is impossible to create, which is why we got no solution there. So thank you, Josh. That was very helpful. That's better, a little better than this picture, wouldn't you say? Okay, so when we get to this error at this point, this triangle doesn't exist. Okay, so you could just say no solution. Okay, there's no solution to this triangle because the triangle doesn't exist. Just understand, geometrically speaking, it just means you can't draw a triangle that has these properties. It's impossible. So the first example we did, everything worked out great, right? Actually, the first 2 examples we did, everything worked out great. We solved the triangle, no big deal, solved the triangle. Now we have a situation where, oh, wait, hold on, it's possible to have no solution. And now we're gonna have another problem. Okay, let's do this one. Why don't I give you a few minutes to see if you can solve this one on your own. And this is telling you you are going to get a solution. Okay, so there is going to be an answer to this. Follow the same process that we did here. But see, what's going to happen here is when you get to this and you do this arc sign, you're gonna get an angle. I mean, you're going to be able to do it, so you're not going to get an error. So just see how far you can go with it, and then I'll step in and run through it with everyone. Okay, let's talk about this. So who wants to lead the way here? Tell me the equation that you set up.
I did sine B over B is equal to sine A over A.
Okay. Yeah, I like this because we have little a, capital A, so we can fill that in, and we have little b right there. So, and you also put the sine B on top, which is good because we're going to be solving for capital B here. Good, this is good. Anyone have any questions on that? I do want to write down what we want over here. We want capital B, we want capital C, we want little c, right? Those are the things that we need. Okay, let me plug some stuff in. Sine capital B over little b, which is 2, equals sine of 40 over little a, which is 3. I will clear the fraction on the left side by multiplying both sides by 2. And then divide the whole thing by 3. All right, anybody else? I don't know who responded just now. Who was that? Anna Marie, was that you?
Yes, sir.
Okay, somebody else, maybe somebody who has not replied today, so I don't have to call on someone. Can somebody who did this far tell me what you got on the right-hand side?
I got 0.43.
I'll put 0.43. Anybody else get that?
I got that.
Yeah, and this is good, okay? This is good because remember, we just said a second ago that if you look at a sine function, if the amplitude's 1, so if there's no number out there, there's really a 1, we know that this must be between -1 and 1, and our answer is 0.43, so we should get an answer here when we do arc sine. So now this is the step we got stuck on last time, but here it's actually going to work. Was that a question? I'm sorry.
I have a quick question.
Yep.
Why are we taking the arc sine?
Because we want to know what capital B is, right?
Mhm.
We don't want to know what sine of B is. We want to know what the angle B itself is.
Oh, okay, okay.
So we're killing off the sine by bringing the inverse sine in. The inverse sine of sine gets us B by itself. Does that make sense?
Yeah, that makes sense.
Okay.
Thank you.
Yep, no problem. Now, when you do this on your calculator, it's going to spit back to you an angle, and it's going to be in degrees. So who did that part?
I got 25.47.
25.47 degrees. Okay, everyone all right with that? So this is potentially what B is here. So let's fill in our answer up here. 25.47 degrees for B. Now that's really good news. Why is that good news? We have B now. Are we going to have to go through this same process again to get capital C?
No.
No, because now we have two of the angles. If we have the two angles, 40 and 25.47, we can get capital C without any work here just by adding up the angles, you know, and seeing what it takes to get to 180. So what I'd normally do to get capital C here, I'm just going to show the computation. I do 180 degrees minus the 40 minus the 25.47. And that will give me what capital C is. 180 minus 40 minus 25.47. So 114.53 degrees. We have an obtuse angle, don't we? You'll see this is obtuse. It's obtuse, it's bigger than 90. That's okay. And now we have one more thing to get, and that's C, little c. So to get little c, I know what capital C is now, right? And I also know what A is in little a and capital A are. So I'm going to go back to kind of like one of the previous problems. I'm going to put C on top, sine of C on the bottom, equals A on top, and then sine of A on the bottom. All the things I know little a, no capital C, no capital A. And the only thing I need to figure out is little c here. So little c over sine of capital C, which is 114.53 degrees, must equal little a, which is 3, over sine of A, which is sine of 40. I clear the fraction on the left side by multiplying both sides by sine of 114.53 degrees over sine of 40. So had anyone gotten that far and got an answer here? Anna Marie, what did you get?
4.25.
What's that?
4.25.
0.25. Jackson, were you going to say something or no?
Yeah, I got 2.83, but it's possible I'm wrong because I have like a cheaper calculator, so it's harder to plug it in.
Yeah, just make sure you're in degree mode.
I got a similar number to whoever got the 4.25.
Same
You
here.
got 4.25? Okay.
Yeah.
All right, so let's do this, 4.25. Let's go with it. Okay, now I want to point something out that I have not mentioned up to this point. That's very important. When you have a triangle, the biggest side that you have will have the biggest angle, and the smallest side you have will have the smallest angle. So if we do a quick check here, let's see. What's the smallest side we have? We have 3, 2, and 4.25, right? The smallest side we have is 2. What is the angle that goes with that? 25.47, right? Smallest side has that angle. Now, the biggest side we have is 4.25, and its corresponding angle is 114.53. So this is the biggest, this is the smallest, and the one in the middle, right? The one that's in the middle side, A, has an angle of 40 degrees, which is between those two. You'll see that? Anytime you solve a triangle, you should have that relationship. Smallest side, smallest angle, biggest side, biggest angle. If it doesn't match up that way, something is wrong. All right, that's a good way to kind of check to see if your answers make sense. Maybe we can do this on here now. It was 2, 3, and 4.25. So 2. Oh, I'll do it in this order. 2, 3, and 4.25. That's good enough. And then what were the angles? See, the angle for the smallest one was what? Can someone, I can't see it. What was the angle that went with the side 2?
25.47.
25.47, so 25, somewhere around there. Do you see how this angle goes with that side? Because it's opposite. And then what was the angle that went with 3?
40.
40? Can't get it exactly, but you can kind of see there's the triangle. Okay, so we have 20 something, 40 something. This is 4.25, that's 2. And then notice that this angle, capital C, the one that goes with 4.2, notice that that one is obtuse, right? That's the 114 or whatever that we got. Okay. Cool. All right, let's look at another one. I'm going to work through this one, okay, because this is the first time we've seen this. This is going to be weird. We're going to get 2 answers. We're going to get 2 solutions. All right, so notice here we have the things that correspond. We have little a and we've got capital A. We have little b, but we don't have capital B. So I'm going to go write down again what we're going to look for. We want capital B. We're going to want capital B. We want capital C, and we're going to want little c. Those are the 3 things we need. So let's go after capital B first. I'm going to write sine of capital B over little b must equal sine of capital A over little a, and that's because I know everything I need to know about A. So sine of capital B over little b, which is 8, must equal sine of 35 degrees over 6. Clear the fractions. Sine of B equals 8 times sine of 35 over 6. So now I get on my calculator. I do 8 times sine of 35 degrees. Divide that by 6. I'm getting that sine of B is 0.764 or something. I'm gonna go to 765. Any questions or anybody disagree? Okay. Now, this step, we do inverse sine on both sides. That will free the B from the sign, right? That will kill that off. We'll get B equals. And now on my calculator, I'm going to do this. Inverse sine of 0.765 and I'm getting about 49.9 degrees. Is that all right? So right now, if we just follow what we've been doing, this is 49.9 degrees, right? And C here we could get, right? C would be, let's see, we can add up A, 35 plus 49.9, and then subtract that from 180. This would be 95.1 degrees. Any questions there? Now to get little c, I go little c over sine of capital C equals little a over sine of capital A. So little c over sine of 95.1 degrees equals little a, which is 6 over sine of 35. I clear the fractions, or clear the fraction out on the left. Anybody have that yet?
Yeah, I got C equals 10.4.
Equals what?
Little c,
Is what?
10.4, well, call it 10.42.
Okay. Anybody else get that?
I got that as well.
Okay. Okay. Wonderful. We got a triangle. Let's check it. Let's check it first, and then I'm going to get to this whole idea that we only have half the answer right now. Okay, so we have A is 6, B is 8. A is 6, B is 8. I really like this, man. Thanks, Josh, for even making me go after this. And then we got C is 10.42. Oops, I hope I can go that far. 10.42. Okay, please help me. What was the angle that went with A? What was the A angle?
35.
35? Close enough, right? 35-ish. And then what was the angle that went with B?
49.9.
49.9. I don't know. I think that we've, are you all satisfied that that's the triangle that we have? Yeah, okay. Now, in looking at the problem that was given to us, we were given A, B, and the angle that was 35 degrees. That's the angle that goes with A, right? 35. So we were given A, we were given this side, right? That's A. We were given B, which is this side, and we were given this angle right here, right? 35.4. Now, this angle right here, do you see this angle right here, 50.4? We found that using the inverse sine, right? Isn't that what we did? Yes. So if I had to highlight again, I'm going to highlight this for you so that you can see it here. This side right here was given to us. This side was given to us. And this angle was given to us right here, right? That was given to us. Do you agree that I have another triangle that would satisfy all of those? And it would require me doing this. You have to give me a moment to do this. Oh, come on. Oh. Okay, do you see that triangle? Do you agree that this side right here, 6, is still 6? Do you agree that this side is still 8? Do you agree that this angle is still the 35 degrees that they gave us? But do you see this angle is now changed and this side is changed? There were 2 triangles that actually satisfied both of those conditions, or the conditions that were given to us. So why didn't we see that? Do you understand there's 2 triangles? That we've only saw one of them? So how are we going to realize that when we're doing our work? The key part of the problem in knowing that we have 2 solutions is right here. Because remember, when you use an inverse sine function, you automatically restrict your domain, don't you? When we talk about inverse sine, we know then that you're not allowed to look at angles that are in the second or third quadrant, right? But just think about what this is saying. I mean, you really have to understand what we talked about before. When you're saying inverse sine of an angle, or inverse sine of 0.765, what you're saying is sine of some angle, in this case, B, is 0.765. So sine of some angle B is 0.765, means that if I look on the unit circle, I would like to know where the y-coordinate, because we're talking about sine here, is 0.765. And that's going to happen up here somewhere. Okay. And in fact, we know the angle, that's 49.9 degrees, right? I don't know what the x coordinate is, but I can tell you that the y coordinate is 0.765. Does that make sense? But where else could I have that angle? If I'm allowed to look in the second quadrant, do you agree that I would also have that here? They would have the same exact y coordinates, right? This y coordinate and this y coordinate would both be 0.765. So my question to you is, then what is this angle? If this is 49 from here to here, then that would mean from here to here would have to be 49.9. So take 180 and subtract 49.9 degrees, and what would you get?
You get 130, pretty much what you had in that triangle.
130.1, right, degrees? So in the previous problem, we didn't do this because I didn't want to freak you out on the first problem. But now we need to actually go back and look at the previous problem, because anytime we do inverse sine, we are going to have to look at this and consider, is it possible that we have 2 angles that would satisfy this, 49.9 and 130.1? We're going to have to look at both. Okay, I'm going to go back up here now, and what I'm going to do is I'm going to say, this is one solution, right? This was one solution. But another solution would be B, capital C, little c, where we just went through all this work to find capital B, and we realize now capital B is actually 130.1. So this is 130.1 here. If I know that B is 130.1 and I know that A is 35, then I can get C, just like we did before, by doing 180 minus 35 minus 130.1. I get 14.9 degrees here. Are y'all following me, what I'm doing? Any questions? And then once I know that, I can go through this work again right here, but I'll be replacing this 95.1 with 14.9. So I'm going to just squeeze that in right here. C over sine of 14.9 degrees equals 6 over sine of 35 degrees. And I'm not even going to show the work for that. I'm just going to do it on my calculator. So you'd have to clear the fractions and stuff. I get C must be 2.69. So 2.69. That is my second solution. And that's the other triangle that I drew. That's this one. 2 point something here, 130 about, and I've got my other triangle. So this having to do the inverse sine function creates a problem. It creates these two roads that you have to consider, all right? So let's revisit the previous problem. And let's see, well, why didn't we have two solutions here, all right? So if we go back and revisit this, right here at this critical step right there, please understand that this means that sine of B, right? Well, actually, it's the line above it right there. Sine of B must be equal to 0.43. On the unit circle, that's going to happen at two places. Here and over here in the second quadrant. Same y coordinates, right? Same vertical distance up. We know that this angle is 25.47 from the calculator, right? From doing the inverse sine on our calculator. But this angle from here to here will be 180. Take away that 25.47. So 180 minus the 25.47. So that would be 154.53 degrees. Are y'all understanding what I'm doing here?
Yes.
So why am I not going to use this? For this problem, why am I not going to do this? But in the problem here, I actually did do it. Why am I going to stop right now at this point?
Because it's not the same value.
I mean, it's not the same.
The angle.
They're not the same here?
Well, because on the last one, when you did it, I saw that you put 49. Yeah, you put.
Oh, yeah. Okay. Yeah, I did the same thing here. What I did was I put here this right from here to here. That is 25.47 degrees. So I subtracted that from 180.
Is
Which
it
is
because,
exactly what I did on the previous problem?
is it because the 154 did not fit within the parameters of the other sides and angles given?
Well, yeah, think about this. If we're going to say that one of the sides has an angle, or one of the angles is 154 degrees, right? That's what we're saying. But one of the other angles is 40 degrees. That's already more than 180. Two of the angles alone is more than 180. It's impossible to have a triangle that's like this. You can't have a triangle with the angles being more than 180, and just two of them by themselves would be more than 180. Understand? As opposed to when you just used a 25.47, then yes, you can get that other angle, C. And so that they all add up to be 180. So to kind of summarize what you're going to be doing here, if you ever have to take the inverse sine, if you ever have to do that when you're using law of sines, you're going to want to look at both of the angles in the first and second quadrants. You're going to analyze each of these answers and see if they fit into the problem, and make sure that the angle doesn't bust over 180, the two angles together. If it goes over 180, you can throw out the bigger angle. If it doesn't, if both of these work, then you have two different cases that you have to look at. Okay. This one was 2, 3, and 40. Let me see here. Let me go back to this thing. It was 2, A was 2, This was 3. And we were given the angle A was 40. So that means this angle is 40 here. And then what we found the answer to be here was 4.25 there and 4.25. Hold on. So angle A was 25.4. So angle A was 25.4. Close enough. We found angle B was, I'm sorry, I've got this all wrong. Angle A was 40. I had that right. What am I doing wrong here? Oh, A was 3 and B was 2. I got these backwards. A was 3, B was 2. And then angle A, the angle for A was 25.4. Jesus. I think it's time for me to call it a day, huh? This was 25.4. Okay, that was what we had. And the things that were fixed, here were this had to be 3, this had to be 2, and this angle had to be maintained. There's no way that I can move this. I cannot change this and swing this out to create a new triangle. Okay, I can get this really close, but I cannot swing this to touch that other corner. It's impossible. So that's why we only have one answer here. All right, I hope that makes sense. All right, what next?
So for the questions like that, would you want us to put both answers, or just like if we find the first one, unless unless it tells us to find the second one?
Nope, you have to. Solving it means that you would find both answers. So if you only find one of the two, then that's not correct. Yeah, so this can be a very important step in these problems, is to make sure you understand that part. Let me see, we've got 20 minutes. Why don't I let you work on this one? Okay, we'll talk about it and I'll let you work on it. So finding the length of a ski lift. So look at this figure. To find the length of the span of a proposed ski lift from point P to Q. So we're trying to find the length from P to Q. Come on. From P to Q. We're trying to find this length, okay? A surveyor measures the angle DPQ, which is this angle right here. Sorry, not that one. That's this angle right here. That's the angle DPQ. The way that works is you start at D. You do this in different color. Start at D, go to P, then to Q. The angle DPQ is the angle in between those. Okay, so they find that to be 25. And then the surveyor walks back 1,000 feet and measures the angle from R to Q to be 15 degrees. What is the distance from P to Q? So basically, you need to figure out that distance from P to Q, and this is all the information that you're given. All right, I'm going to see if you can handle that. If you're able to do that, I'm going to put another problem up below it, and you can start working on that one. Okay, I'll give you about, I don't know, see what you can do in 10 minutes. All right, and then I'll call on someone in 9 minutes. Okay. I just launched a poll. If you finish the first problem, just click yes. Don't click anything until you've finished the first problem. I just want to see how long it's taking people to get the first one. If you do have a question on the first one, if you're having any issues getting started on it, just send me a chat. I've started drawing a picture of the triangle and labeling the sides, which can help you get started on that problem.
Professor, for the first question, I keep getting that PQ equals 0.000046.
You're getting that distance is 0.00046? Is that what you said? Okay, yeah, something's
know what's
something's
going on.
off there. Do you have a triangle like the one I have drawn here, kind of, or no?
Yes.
Okay. Yeah, let's just go another minute and then we're going to go through it. Okay, let's talk about this one. So I think the first thing that you want to do is just try and draw a triangle and label the sides, you know, A, B, C, however you want to label them, A, B, C, little a, little b, little c, and then label all your angles, capital A, capital B, capital C. Just remember those angles have to be across from the side. So if you call this little b, that's capital B. You call this little c, that's capital C. Call this little a, that's capital A. So the first thing I wrote down was that A is 1,000, that's given to me. I also know that angle C is 15 degrees because that was given to me. This angle here, which I'm calling capital B, was not given to me, but I was given that this is 25 degrees. And so it's important for us to note that if you go, you know, a straight line, straight across, that's 180 degrees. So if this part from here to here is 25, you can take 180, subtract 25, and that's where you get 155. Is that clear to everyone? Now, if I have that this is 155 and this is 15, together you add those up, that's 170. That means this angle has to be 10 degrees. And so that's basically all the information that I can gather from just the drawing. Now, I would like to know what little c is, right? I mean, that's what we want to know. Little c is the length of this side, and that's what we're looking for here. So if I want to know little c, I'm going to put little c over sine of capital C must equal, now what do we have? In terms of sides, we have, all we're given is little a is 1,000. So I'm going to be doing little a over sine of a and capital A here. So that means we have, I'm going to run out of room. I'm going to have to scroll down here. Let me clear that out. Okay, so we're going to have little c over sine of capital C. So capital C for us is 15 degrees, must equal little a, which is 1,000, over sine of capital A, which is 10 degrees. I isolate the C by multiplying both sides by sine of 15 degrees, and then divide by sine of 10. Maddie, did you figure out what went wrong? Cameron, did I answer your question?
Yeah, I did. I ended up getting it.
Okay. Maddie, did you see what happened for you? Yes? Okay. All right. So when I do this, I get, you know, approximately 1,490.48. And then I guess feet, right? Because this is measured in feet. There we go. So in this problem, we never used inverse sine, right? We never had to do the inverse sine at all on our calculator. And so we didn't have to worry about two possible triangles, which is great news, right? Are you all good with that? Okay, so what I'm going to do is this other problem that I gave you, I'd like for you to work that up on your own. And I'm going to take it as something that is required to be turned in on Monday before class in the same Dropbox as the test. So if you do the corrections, send that as one thing, and then send this problem as another one, as another file. And I will use this as a bonus question for the test. So more points that you could add to your test grade, all right?
The height of the airplane question is the bonus question.
The what?
The height of the airplane.
Yeah, this problem is a little different because you have, well, I don't want to say, yeah, but you're trying to find,
But
You're
the
trying-
question, that's the bonus.
yeah, you're trying to find what that is. Okay, so you're going to have to take what we've learned here today, but you're also going to have to add a little bit to it, you know, thinking about what other things you might be able to do to figure things out. Just, yeah, I'm just gonna have to let you, you know, I want you to try it. If you get it wrong, you get it wrong. I'm only gonna count it as a bonus, but I want everybody to try it, all right? Okay, so we'll call it a day. I'll hang out here if you have any questions since we have a couple of minutes left. Again, Monday is just going to be test corrections and then this problem, and then the homework. Let's go ahead and 9.2. Go ahead and start the homework. Try it. If you get to the word problems and get hung up, that's okay. I'll work the solutions out for that section the next day or so. Okay.
Thank you, sir.
Okay, everyone have a good one.
Thank you.
And when is the Dropbox, like the bonus and the question, like test, where you do thing? I can't remember what you called it. When is
Test
that?
test corrections, and this problem,
When does that do?
Monday, 9 a.m.
Okay.
So
Thank you.
before we meet again, have it submitted.
Have a good weekend.
All right, you too.
I have 2 questions.
Yes, ma'am.
The Dropbox hasn't been working for me. Do you think I have to like create an account with Dropbox in order for it to work?
What are you trying to send it through? Just a computer, just like a laptop or something?
I go to the Canvas app on my phone. 'Cause that's how I take pictures and then I send it through there, but like it won't open the link.
So when you take pictures,
I have like an Adobe scan, and
mhm,
so it compresses it all into like one PDF file.
mhm.
And then I go over to Canvas and I go to click the Dropbox, but it won't open.
On your phone,
On my phone, yes.
can you try it on a computer?
I can try it, yeah.
So what I think you would need to do is from your phone, send that file to like email it to yourself or something. Like share it with yourself as an email,
Mhm.
and then take that and once open it on your PC and then send it through there. See if it works. I don't. If worse comes to worse, just email it to me again. But I think it's because you may be trying to do it through your phone, but I could be wrong.
Okay. And then am I allowed to do the corrections as well?
Everybody can do the corrections,
Okay.
but you can only get back a certain percentage of what you lost. So if I only took off like, let's say 3 points, you can get like 30% of that back. So that would be
Okay.
like 1 point or something. You know what I'm saying? Like
Yeah,
you
makes
can't,
sense.
so it's not going to be like everybody gets 10 points back.
Hmm.
So, but it'll increase your grade a little bit.
Okay.
Okay. Mm-hmm.
Have a good day, sir.
You too.
Bye. Have a good weekend.
You too.
Oh yeah, I had a question
Okay.
for you. So basically,